Hello guys, welcome back once again in my YouTube channel. My name is Krishna Rai and today in this video I'm going to cover how to use left shift, right shift and bitwise operation. So let's start the video. So first I will start with taking a variable, and the variable is, let's say, byte. Byte is the data type and I will write a binary value. So it's 8-bit basically value I will take. So let's say this is the value. Byte type A is holding this binary value. Now what will happen if I do a left shift with 2? So what I'm trying to do, I'm trying to shift 2-bit from the left side. So 2-bit from the last thing from the left side will be removed. So what will happen in this case? Now 2 bits are going to be replaced. So the new value which A will be holding is 0B, and what thing is left? So you guys can see here what is here. Here we have 0 1. 0 and 1. Okay, so same thing will be here. Here we will have, yeah, 0B, 0 1, and again 1 2 3 4, because 40 was over here. You guys can see there were 40 after 1. So 40 I have placed. Now how many bits are now? 4 to 6. So automatically right side, now 2 bits will be add on. 2 bits means basically 20 will be add on to the right side. Okay, because 2 bits are removed from left side, so automatically whatever bits will be removed from the left side, same 0 will be add on, same number of 0 will be add on the right side. That's how this works. So do you know what is the value of this one in decimal? How we can calculate this value in decimal? By doing this thing, we can just do this operation. What is the position of this? This is 0th position, this is first position, second position, third position, fourth position. So 1 is on the 4th place. How to do that? 2 into 2 into 2 into 2, because we are converting binary into decimal. 2 to power 4, and then we will multiply by 1. So the value which will be there is 16. The value, the initial value was 16. Initial A value was 16 before the shift of operation. Now after shift, what is the value of this A? After the operation, what is the position of 1? 0, 1, 2, 3, 4, 5, 6. Now 1 came on the 6th position, 6th place, right? So what will be the value of A? Again we have to multiply 6 times. 2 into 2 into 2 into 2 into 2 into 2, and then into 1. What will be the value? 2 to the 4 to the 8 to the 16, 32, 64. So did you see that? What I did, I just applied shift operation, left shift operation, and I moved the bit, left side 2 times, and then what I got 64. So what is the difference? 16, if you are moving towards left, you are getting multiplication. 16 into 32, 16 into 2, 32, again to 64. So 16 basically I multiplied by 4, because 2 time shift is there. So 2 into 2, 4, right? So this is how basically left shift operation works. I will also show the same thing on Tinkercad. Now we will understand left shift operation by this practical. So I have Arduino board over here, Arduino Uno board. and already I have done the wiring of this LED. Positive of LED is connected to pin number 3. So 0 to 7 is basically port D, and negative of the LED I have connected to GND. So if you guys are new to know port of the Arduino board, so I have already made a video for bare metal programming with Arduino. I have attached the video link in the description. So first do watch that video and come back here so that you will understand how does bare metal programming works, how what is DDRD register, what is port D register. Now in this video I'm just going to explain left shift right shift operation, as well as I will show bitwise operation, right? So now I want to turn on third number pin. So there is another register called port. With this I can just send one binary value 1 to third pin. See, I am sending binary value 1 to pin number 3 because that's what I am interested in, right? Now if I do start simulation, this LED should glow. Let's see whether, yeah, so the output is in front of you. So by doing this I can access all the pin. I just need to send one binary value. This is one is basically a binary value which we are doing left shift, whatever pins we want to send. Let's say this LED is connected to pin number 5 instead of 3. Now I have changed the pin. Now it is connected to 5. That means I have to make 5 pin output. Fifth pin, let's set as output. Fifth pin is here. Now fifth pin is set as output, and I just need to change this number, and there you go. You will have the output. Yeah. So actually there is one problem. Fifth pin is this one, not this. That's why LED was dim actually. Yeah. 1 0. Yes, now it should work. Let's see. Now the LED is brighter. So it start from here. This is 0th pin. 1 2 3 4 and 5. So total 0 to 7. We have 8 bits, right? And I'm just sending binary value 1 to 5th, and I'm doing left shift. So the one value is shifting 5 times, right? 0 1 2 3 4 5. It came on the 5th position, right? That's how left shift operation works. But here there is a question: can we do the same thing with right shift operation? So the answer is not. Can we do this if I want to do, if I'll do 1 and let's say 2, because you would be thinking like 0 1 2, right? You would be thinking I just need to shift 2 times to turn on this LED. But is it going to work? Let me just show you the output. It's not going to work, because what actually we are doing, I will explain you this over here. Look, so when we are doing that thing, the value was what we were trying to do. Let's say instead of port, I will write here port D equal to what we were trying to write, 1 shift 2. What this is meaning? This meaning is you have some binary value. Let's say 0 0 0 0 0 0 0 1, right? You have this binary value and you are shifting one, 2 times. This one you are shifting to right side. So when you do that, this right side shifting, you know this one will be gone and you will have only 0 left. Okay, because in right shift you are, your right side bits are going. In left shift your left side bits are going. That's what happens, right? That's what we have seen here. When we are doing a in this operation, 2 times shifting. So because this was, right side, so you can see one came in this position. Here one was already in first position, so it will go and automatically 0 will be add on the left side, and you will have port D. What will be the new value if you are doing this? The new value will be 0 0 0. 0 0 0. So as you have seen that when we are doing this right shift operation, the LED is not turning on, because we understood, right, when you are doing right shift with basically two times we are shifting with one, so we are getting port D equal to 0, right? Now we will understand OR and AND operation, because that is very important. Left and right I have covered. Now let me explain you operation, bitwise basically operation OR and AND. So let me take a value. Again I will take byte A equal to 0B, okay, 0 0 0 0 1 1 1, let's say 1 only, 0 0. Okay, so I have this value. Okay, I have this value, font family, yeah, yes. Now if I am doing this A equal to A, or with, let's say 2, what I'm trying to do, I've done this operation. This is OR operation, basically single, vertical bar. This is called bitwise OR. Okay, bitwise OR. So what I'm trying to do, 2 is basically decimal number I have written. In binary it will be 1 and 1 0, right? So if I'm doing this, what will be the value of A? What will be the updated value of A? Let me explain that. A equal to A and or with 2, right? So let me break down this. Over here, what will happen? A equal to 0B 0 0 0 1 0 0 0 0, right? And we are doing R, so the value will be 0 0 0 0 0 0 0 1 0, right? So this is 2, 1 0 is 2 basically in binary. What will be the updated value? R means basically adding, right? 0 B 0 0, right? 0 1 0 0 1 0. This is the value which you get after this OR operation. Okay, what AND operation will give? Now let's say we are doing AND. A equal to, if I'm doing A equal to A and with 2, what this will give? So I will note down that also. A equal to 0B 0 0 0 1, same value I'm writing so that there is no confusion and you guys understand this properly. Again same thing, 0B 0 0 0 1 0 0 1 0, because the 2 in binary, 2 is basically 1 0. Okay, here this was 0, right? Now what will be the output? The output will be here. So when I'm doing AND operation, AND is basically kind of multiplying, right? So you'll get 0 0, 1 into 0 will be 0, again 1 into 0 0 0. So when I'm doing AND, actually what I'm doing, guys, did you notice that when I'm doing AND, I am clearing the pin. Now the value is becoming 0. But when I'm doing OR means whatever bits I am interested, like I was interested in second bit. Now you see that second bit is set. When I'm trying to clear the bit, second bit is clear now. Look here, second bit is clear. Okay, so when you are doing OR, you are actually setting the pin. When you are doing and you are clearing the pin, right? Let's replicate the same thing in Tinkercad. You will have clear understanding and an OR bitwise operation, as we have learned that. So let's do port D or let me or equal to. Now what we will do, one we will send to pin number 5th. So I'm using left shift operation. Let's see. So OR means basically we are setting only we are interested in only fifth number bit. So there is a problem, there is a basically difference. There is a difference between if without or if I'm sending one, if I'm just using this thing, what this can do, this can disturb the other pins also. Let's say some other pins are high, right? Because I don't need all the pins. When you're saying this port D means you are trying to, take all the bits 0 to 7. But no, I just want to change that particular bit, pin number 5. For that, I have to do OR operation here. If you do OR, it will just, hit that particular thing. For an example, I'll explain you. For an example, see there was a bit here. This bit was high. Did you see that? This bit was already high, right? And I am interested in second bit because that's what we did, right? So when we did OR operation, bitwise OR, the second bit is changed and this bit is as it is, right? There is no problem with this bit. That one value is as it is, but this bit became 1 because I was trying to basically send on second number bit. That's what it did, right? Now same thing, let's say I want to write a program for LED blinking, right? So let me put a delay of 1,000 delay, and now I want to clear the bit. So for clearing, I have explained, right? What operation? For clearing, what operation? And bitwise and which pin we want to clear? Fifth number. If I do this, I'm just doing and with the same thing. Now it should blink, but there is no delay, so you won't be able to see that turning off. So again we have to put delay. Now let's see the output. The output will be amazing and you will have clear understanding how does all these things are working. On. Why it's not turning off? Let me see that. Port D and equal to, okay. Now and we are doing, and then with the and we have to do negation because I want to send 0, or what you can do instead of this, you can send this also. This will work because I want to send 0, that bit. Look, this is working. It's turning on and off. So and is basically when you are doing and with that bit, it will just change that bit. Same thing is happening here. When you are doing and, right, with 1, because the previous value was 0, so it became 0, 1 into 0. So now same thing if you do and over here. So and is basically for clearing and or is for setting. So I hope you guys understood this thing in proper way, right? If you have any doubt, you can, I would love to receive your comments, so please comment and suggest me what is the next video which you are looking, from my side. Thank you.